Hi gang, I'm going to help you review for test 1. So what's going to happen for graphing a polynomial function? The computer is going to generate, it's not going to match this, but the computer is going to generate 6 graphs. It's going to give you 2 equations on the top, and it's going to ask you at the bottom to match the 2 equations with one of the graphs. So I'll just go through this with you so you can see how it's done. Again, this won't be the same example on the test. It will generate different functions, okay? All right, so this is how you're going to do it. So if the function is not factored, I would suggest you start with factoring it. So I took the first function at the top. So you can see here, this function here, I grabbed the top one here, I'm working on that. So I took out the common factor of negative x, and then I factored the trinomial at the end. Then I did the leading coefficient test. So remember, when you do the leading coefficient test, you need the lead term of the not factored form. So that would be negative x to the third. Now, if it's an odd degree, a 3, a 5, a 7, the ends of the graph go in opposite directions. If it's an odd degree, the ends of the graph go in opposite directions. So it's either going to be down, up, or up, down. The difference is that if it goes down, up, it means that the leading coefficient is positive. If it goes up, down, it means that the leading coefficient is negative. Now for us, again, we have degree 3, but our leading coefficient is negative. It's less than 0, which means that our graph on the ends, on the left side, it'll be going up. On the right side, it'll be going down. So whatever's happening in the middle, on the right side, it'll be going up. On the left side, it'll be going down. So remember, the leading coefficient test tells you the end behavior of the graph. All right, so now let's move over to the x-intercepts. So I factored my function. X-intercepts are off the factored form. I factored my function. I've set it equal to 0. I'm now going to solve out each of the multipliers. So I set each piece equal to 0. I solve out. So I'm getting that these are my 3 x-intercepts. You want to label whether your intercepts are even or odd. How you decide that is you look at the factored form, the exponent of the factored form. So this is first degree, this is first degree, this is first degree. The exponent on each of the factored forms is first degree. That's why I'm calling this odd, and this odd. So what it means is that locally around each of these x-intercepts, you're going to go, the graph is going to go through the x-axis. Okay, so just to have like a rough sketch before I compare my picture, I have something here at 0. I know it's odd. I have another one at 2. I know it's odd. I have another one at negative 4. Okay, I know this is odd. Okay, and now I can go ahead and draw the picture. So odd means it goes through, so that means it's going to go through at negative 4. It's going to go through at 0, and it's going to go through at 2. And of course it has to line up. It has to be, so you can see it's going up on this side and it's going down on this side. So once I sort of scratch out what the graph is on my piece of paper, I can go ahead and match it. So if we look back up at the options, so the first thing I'm going to look for is things that go up on the left, down on the right. So up on the left, down on the right, up on the left, down on the right. So these are the only 2 that are up on the left, down on the right. Now I'm going to look for my x-intercepts. So there's 0, 2, and negative 4. Okay, that doesn't have 0, so that's not right. Okay, this one's got it. 0, 2, and negative 4, and they all go through. So I would answer this first one. I would hit choose one. And I would pick graph F. So the answer to the first part is graph F. Okay, gang, I'll make you another video for this example. Bye-bye now.